All right, well, let's do it here. So if anyone didn't see the note I posted on the Discord channel earlier, we have a little bit of a scheduling change. We were originally going to have one of the contributors to Caliban come and talk to us about some performance optimization work that they've been doing there. But they got sick. So I think something's clearly been going around because we had Nabil get sick, and now we had Kiri get sick. So our new schedule is next week is going to be the Akita ZIO HTTP session, and the following week we'll have the Caliban performance optimization session. So both those are coming, but just slightly delayed. And today we're going to start talking about ZIO Schema. That was actually, I think, the topic that people were most interested in learning more about in the poll that we did. So we'll probably do actually several sessions over time on ZIO Schema, on different aspects of it. But today I really wanted to get started on just building the intuition of it. So let me share my screen here. Make sure I've got the right thing here to share with you. Hold on a second. This. Yeah. And hey, Juan. Hey, Adam. Hey, Works. Okay, here we go. All right, and let me try to make this bigger. Okay, that's probably nice and big. Okay. So I think probably where folks saw ZIO Schema before, most recently, at least in what we did, is when we were doing the actor stuff, where we had a bunch of stuff where when we were working with these actors, we needed these schemas for basically the messages that were going back and forth between these actors, both what was going in of saying like, hey, I want you to increase the temperature, as well as the responses of the actor saying back, I did increase the temperature, or I did this. And at the time we said the schema kind of knew the structure of this data. And so we knew how to serialize and deserialize it. And so internally, if we can find like an example like here, we actually use the schema to create a JSON codec, and then we use the codec to encode this stuff. So this was cool as far as like we want to do this distributed actors example, and there was already a lot of complexity in just how we were sending this back and forth, and the schemas kind of helped us solve that problem by allowing us to be able to serialize and deserialize this data that we didn't know necessarily what it was, right? The user could create any type of message and response they wanted, but we needed to be able to serialize it, and this kind of let us do that. So this serialization is definitely one kind of common use case for ZIO Schema, but eventually we'll see there are other use cases. And I also want to hopefully get us to a point where versus this schema just being some kind of magical thing where, well, we need to make sure we request it in the right places so we have it. And then at the very top, we just need to derive it, like having a little more of an idea of like what this thing is beyond just being this black box. And hey, Nabil, look forward to having you on here next time. Okay, so to start to explore that, I just created this little example project here that right now doesn't have anything in it other than saying hello to us, just so we can make sure that this is actually compiling. And I'll do project schema. Sure, it's compiling. Okay. So let's talk a little more about what is a schema here. Yeah, and Nabil, you can definitely, I mean, you're a heavy user of it in ZIO HTTP, so you can definitely jump in here. But let's just talk about kind of building this intuition of like what is a schema. And so my yes, you have been contributing. And my I guess one sense answer would be a schema I'll say describes the structure. I can't quite do like underline or something or italics, but I'll say the structure of data as a value. So to make this more concrete, imagine we have something like a person with a name that's a string and an age that's an int. So most of the time when we work with something like this, we're working with the data itself, right? So I would do something like val person1 is equal to person, and that would be Adam 42. And so this is a person itself, right? This is one concrete person that has a particular name and a particular age. So we could say that maybe if I split this onto different lines here, this thing here on this line, this is a particular person, right? So it's not the structure of a person, but it's this particular person. And then here we've got this person type. And so this is a type. I can do some things with this type, right? I could do like as instance of or something like that. But here we've got person type. And the person type does know something about the structure of a person, right? Like it knows that it has methods like name and age on it. And I could do something like is instance of to sack like one thing is instance of a person or not. But this is a type and not a value, right? So if I have this person thing here, I can maybe construct a person just because a case class has a construct method here, but this thing here, it's a type, it's not a value that I can do something with. So let's try to think together about if we wanted to describe the structure of this person, what's the information that we would need? Anyone want to jump in here with one thing that we would need to know here? Don't have to kind of have everything, but just maybe throw in one thing that we would need to know to understand the structure of this person. And it also doesn't have to be in code, just in words. Okay, so I see Juan's typing. So Olivia is typing, great. Okay, so Juan says it's a case class with two attributes, its names and types. Yeah, so I think that covers a lot of it. So I think we could say this is a case class, or maybe more generally, we could say it's maybe like a named record or a product. Yeah, those are all kind of ways we could describe that. We said it has two fields. Say the first field is string and its name is name. Second field is int and its name is age. I think that covers everything. And I think Olivier got to, yes, got to most of the stuff here. And then, yeah, so I think Nabil probably gets to one of the things, maybe the last thing we have missing here, which is I'll call the name of the case class is person. And maybe if we want to be more technical here, we say this is actually like example.person. Would everyone agree that this information here exhaustively describes everything about this person case class we've defined? Olivier raises a question about inheritance. So we could definitely make this fancier if we say something like, let's say, trait talker, and then this like stands talker, and then this has some thing that will do something. I think this is where we're going to go back a little bit to this idea that, so before I emphasize this structure, I think the other thing maybe we can emphasize here is like data, that this has to be something that we can, I mean, a lot of this is like something that we can fully describe, and we could like serialize, we could like write this to a database. And so one of the things that we're actually, I think, going to have to accept is that some things may not have schemas associated with them, because I could have some trait that has a bunch of just arbitrary methods that do completely arbitrary things, and we can't necessarily capture that in a structured way. So I think here we're going to focus more on this idea of data. And so this would kind of be an example of data. If I have something of like, I don't know, let's say trait Kafka processor, and, it's going to have some kind of process transaction. This is something that there probably is not going to be a schema for, versus this is something there is going to be a schema for. So I would think about that. So we talked about the structure, and I would think about this idea of data. So like one of the other things I sometimes suggest with people with Scala is, as a pretty good simplification, you can say everything should either be a trait or a case class. And so again, to kind of slightly simplify, you could say you've got the whole world, and everything is one of two things. It's either an interface that's represented as a trait, or it's data, and that's a case class, or a, basically, sometimes we would do sealed trait, or I'll call it sealed trait, with case class subtypes. Everything falls in one of these two categories. And so this one here, this is kind of focus of ZIO Schema. Yes, you have objects too. You can definitely have objects too. Okay, so basically not this, but things like this. So I think if we take that as which I think is a definitely good qualification to raise, I think we could feel pretty good that, admittedly, this is pretty simple data here, but that this really is these things would fully describe this, the structure of this data type, right? That if you kind of, imagine almost that I like covered this up so you couldn't see it, and I say, hey, I want you to create a data type that is a case class that has two fields. Its name is person, its first field is a string, its second field is int. We can kind of do the exercise ourselves, and that literally fills in everything here. So you can think of ZIO Schema at the first instance as basically trying to say, okay, how do we take this idea and actually represent this, and not words, but in code? And we'll kind of do a mini example of this. And then how do we do it for all the different types of data? Because we can have case classes that have two fields. We can have case classes that have 20 fields. We can have case classes that have case classes inside them. They can have chunks inside them, right? There's more than just this person that has two fields, though this is a good starting point. So let's start to explore a little bit what this looks like. And I think what I'm going to do, at least in this session, I think maybe in some of the other ones we do with ZIO Schema as well, is we'll bounce back and forth a little bit between, we'll do some coding ourselves and to kind of build the intuition, but I think this is a library where there definitely is like, there's reason that it's a library and not that we all do it ourselves. So I'll kind of flip back and forth between that. And then we'll look at like the actual implementation of some of these things in ZIO Schema. And we'll see how maybe they did a little bit more there or what this looks like when we take it beyond a simple case. But let's start to explore this. So I think in this example, we've got basically you could think of as like two things. We've got these, we could probably call primitive types, right? So we've got this string and we've got this int. And then we've got this composite type that puts them together. And if we remember some of our stuff about data modeling and kind of going back to here, to somewhat simplify, we could say all data is either a sum type or a product type, right? And so sum is A and B. Sorry, excuse me. Product type is A and B, right? So that's like a person has a name and an age. And sum type is either A or B. So that's like a payment method is either credit card or check. I don't know how many people are actually using checks now. Maybe we should change our examples to use like Bitcoin or something. Okay, so if we build on that, we might say, well, our first thing here, let's start to create our own little data type here. So I'm going to create a sealed trait schema of A. And so here, just to kind of make sure we're thinking of this right, we're going to say a schema of A describes the structure of a type A. So for example, a schema person describes the structure of this person data type above. So we're going to make this a sealed trait so that we know that all the schemas that exist are the subtypes that we're going to allow below. And we're going to create like maybe we're only going to create a few of them right now because potentially that's one of the areas where there's a good number when we kind of want to cover everything, but we'll get there. But let's start with these primitive types. And this will also maybe be a little bit of an exercise in like domain modeling for us. So we're saying one type of schema is just these primitive types. And so maybe we have something like trait primitive extends schema. And we'll need these to have type parameters as well. And so then we could do something. Maybe we call primitive, maybe we'll call primitive type. And then maybe we'll say we've got object primitive type. And I'm going to make this a sealed trait as well. So I know that the only primitive types that exist are the ones that I allow here. And initially, we're going to do the minimum possible we need to make this example work. And so I might have something like case object string type extends primitive type string and case object int type extends primitive type of int. And oh, I just made this thing up, so let me get rid of this. Okay, so a couple things to notice here is one, I'm using these like string type instead of string. So we distinguish like this is the schema that describes the structure of a string. This is the actual Scala string. So we keep those two separated. And there doesn't necessarily have to be a one-to-one mapping between these primitive types and what would be a primitive in like Scala or Java, or like what would be a value type. So like string, maybe we say, well, you could represent a string as like a collection of characters or whatever, but maybe for our purposes, we say strings are common enough that that's one of the things that we want to be kind of the base layer that we build on. So that's going to cover this and this. Now we need this thing here. So we could either call this like a record or a case class or a product type. Maybe for my purposes here, maybe I'll call this a record type, say. And so this is going to be another kind of schema. And so someone says, is there a macro to generate the ADT? So later on, when we get to ZIO Schema itself, that's kind of what you're getting to of if you use ZIO Schema, and maybe we can go back to our other example here. Where do we have that? Yeah. So like here, when we're using the real ZIO schema that has all the fancy stuff built in, there's this derived schema.gen. And so this basically just says, hey, I see this thing as a case class. I see what's inside of it. I see its value. And there's basically going to be either a macro implementation here that's going to construct all this stuff for us. But what we want to do now is we're kind of, I guess, we're on the little tricycle learning to bike before we bike ourselves. So definitely, yeah, as a user of ZIO Schema, there's basically no need for you to ever do this or put one together yourself. But I kind of want to actually do this because I think there's a little bit of it's the good and the bad of doing it this way. Of when we went through the ZIO actors example, we spent the whole time and all we did was, well, this is a case class, so we derived it and then we just used it. And it's great, right? You don't have to think about this, but it also means it's like a little bit of maybe a black box what the schema is. And so maybe that's great if that's all you want to do, then fantastic. But I kind of feel like the point of the Zymposium is kind of some people like they really want to understand like what's inside there to like feel a little better about it, maybe feel more confident about it, know exactly what they could or couldn't do with it, or why they can do things or can't do certain things with it. So that's why I'm like actually kind of pushing us to be pretty explicit here, at least in our initial thing. It's like when we have to like, I don't know, do the math in like school before we get calculators or whatever. Okay, so I'm gonna have this record type thing. And then I think similar to this, and I don't necessarily have to have these objects for things. I could just put everything at the base level here. But I think right now I'm gonna do it here. And so maybe I'll have something like final case class record type 2. This will have an A, and we'll think about what else it has in here. And this is going, right now I'll just give this a parentheses here. And so this is going to extend a schema of A. And so this, if we say this represents kind of any possible record type, so this could be one that has 0 fields, one that has 2 fields, one that has 22 fields, and maybe one that has 100 fields, if we're going to support that. This is a specific one that has 2 fields. And so, okay, that should theoretically let us represent this thing here, but clearly there's a bunch of information we're missing here. So let's try to kind of build that in. And we'll start simple, and then we'll kind of add to this. So I think the first thing we might want to have here is a name. And right now, I'll just make that a string. Nabil, I think, raised a good point of like, is this the named person or is this the fully qualified name? Maybe we want to have both of them. So you could imagine eventually this will become like a more structured like name type that maybe captures like each level of nesting there. So we aren't just represented as a string, but let's kind of start with basic stuff here. And then if we're going to have a schema for this type, if we're going to fully describe this type, then in addition to knowing kind of the way these things are put together, we're going to need to have a structure for each of these types here. So at least an initial take on this might be something like right? So our person is going to have a name of person, and then we could imagine we put our string type and our int type schemas here. So maybe if we just create a running example for ourselves now, and again, like we will eventually derive this, but let's be super explicit here. So we could say val person schema. This is going to be a schema of person. And so this could be a schema dot record type dot record type 2. Even get to those yet. So this is starting to take some decent progress towards describing the structure of this person. What's still missing here of the things we identified? Yeah, so the names are missing. So one thing I could do here is I could do something like name, maybe I'll call it like field name 1. It's a string, and then I could have like field name 2. That's a string. And so then this thing could be name and age, right? I think that would capture everything. Now, this might not be as nice. Maybe what we'd like to do is have something else here. Maybe let's say in this record type here, we could also have some concept of maybe we say final case class field with A, and maybe the field is going to contain a name and a schema. And so that way we can clean this up a little bit. And we could say this is field A, and this is field B. Or, yeah. And then I could go back here, and now this could be a field. This could probably be nicer with imports, but right now we'll just do this. And so now this will be name, and it's primitive type, and this would be age. You got that right. Oh, no, it's not field B, that's just a field. Okay. So now that's working. And then maybe we could do something like, let's see, maybe down here, let's do something like final case class name, and it'll have some segments. And this will be a chunk of strings. Maybe I'll say it's got to be a non-empty chunk of strings because I want to say there's at least one thing in here. And then I could change this to be a name. And maybe I could make a little, let's say, object name. And can apply method for it. And then I can go up here. And this can be schema dot name. Olivia says schema could hold the name. Well, I think we are saying that schema holds the name. I guess we could put in different places here of, we could like have a schema name and then the type, but schema does just indirectly hold the name here. And so now by splitting this out, now we have a little bit more options of how we want to do things with this, right? We've preserved a little bit more information because we can either render like a fully qualified name or a non-fully qualified name. So looking at this now, would we agree that this captures all of these things that we identified down here? Okay, I'm going to take silence as assent here. So ZIO schema, you can think about as basically being taking exactly this and just expanding it, right? So there are a couple of directions that we can kind of expand this, I'll say. So one obvious one is more cases, right? This right now is very limited of like, we can only describe strings and ints and case classes that have two fields that are some combination of those two. Though notice even this starts to have some richness of, let's see if I can think of a good example. So let's see, even this, I could say something like final case class couple is two people. And even this, even with our very limited representation right now, I could describe the schema of this thing, right? Because it would just be a record two. And instead of putting record types in there, I would put the person schemas in here. So in fact, just so we can do that, maybe like as a quick exercise to build on this, we could say about couple schema couple is equal to. And so what this hopefully is starting to give you intuition of is the way that these things can get nested inside of each other. So here, I didn't have to repeat all the structure I had for the person because I could just reference the person schema. And so even with like this like super simple example we've done so far, I could actually describe like both an infinite number and an infinite level of nesting of these types. And at some point, we're going to just run out of memory in our machine. But theoretically, I could describe all of that just with this. But at the same time, there are a ton of things that I can't describe with this. So if I have something like, again, the CL trait payment method, and it's got these like credit card and checks, well, I actually can describe the check because it's a case class with two fields and they're both strings. So I'm good here. But this one is 3. So that's probably pretty straightforward, right? We could imagine how I could extend to that, right? That's probably pretty easy if I can just grab this thing here. And I can do 3, A, B, C, D. So now I can describe the credit card as well. But what I don't have yet is a way to describe the payment method. I don't have a concept for this either or. Okay, so Juan asks a good question here. He says, why model record type 2 and record type 3 and not record type n? So let's look at that for a sec, because I think that's a good like kind of thing to build our intuitions here. So instead of this, I could have something like, let's do this record type n. And I could just say fields. What's the disadvantage of this versus this? Yeah, it's not as type safe. So for example, we haven't gotten there yet, but one of the use cases we're going to want to have for these schemas is we're going to want to be able to do some types of, let's say, schema migrations. And so it would be nice to be able to know that, like, hey, if I'm taking a record type 3, I'm going to give a record type 3 back. Or it'd be nice to know here are the types of these fields, and the types of the fields line up somehow. Versus here, we're a lot more flexible, but that also causes us to lose some information of there's nothing kind of going from one record type n to another record type n to say that you have the same number of fields. Or even in this case, they have the same type. So I think what we'll see when we get to the real one is kind of we go through this, which I mean is a little bit of pain, but I think you can imagine how like Copilot would be pretty good at going through these up to like 22. And then I think kind of like, so if you want like an extra large one, then yes, sorry, that should have been a shock, excuse me. Then maybe we have to fall back on something like this. But part of the idea here is we're trying to represent this stuff as data in a very type safe way, where at least at the library author level, we can work with these structures and do things with them in a way that's going to be reliable and not going to have bugs, and is going to have the compiler help us. So that's why we're typically going to do something like this, and something like this would kind of be like maybe like a last case fallback. So one thing here is obviously more cases. So we did the just more arrays, but there's a lot more here of, we could say more primitive types. We could say the some types in addition to product types. And then I think when we really get into it, we're going to realize there are a couple more concepts we're going to need. Like we're going to need a concept for like collections, right? Of right now, if I have something of like final case class family, and yeah, well, here's a really simple one. So I'm not able to represent this yet. Maybe I can if I change it to be this like case class n thing, though it's actually not quite the case class n, because notice this has one field that has a bunch of persons that are not themselves named fields, which is different than having 100 different named fields for persons. So this is the kind of thing, when we get into this, we have to be like very precise about the structure of these types, because things that seem the same but not exactly the same, we need to make sure we're representing differently as data. So one direction is just basically covering all of these things. And so the idea would be, when we're done with this, anything that we agree falls into this category of data as opposed to an interface, we can write a schema for like this. Then I think a second direction we could go is we could say provide them automatically, right? That was kind of Terry's point here of, hopefully this has been helpful here to get like a sense of what goes into a schema, but you never want to do this yourself, right? I mean, these were like super simple and for this like pedagogical purpose, and this is still annoying. And like, if you had your like giant business objects, you'd never want to do this. So we want to have this functionality. That's, I think, what we saw here. I mean, the name is not that important, but basically you just have something that, as long as it is data, like here, it's this chunk of bytes. All you do is the way we do it in ZIO Schema is you just do derive schema.gen. You put in the type and you get a schema out. So you never have to do this yourself. So the third, I think probably the most important thing, is things to do with these schemas. Because so far we've talked about the schemas, but we haven't really done anything with them. But it turns out there are a whole bunch of really useful things that you can do with these schemas. And I'll hit on a couple here, and then we can come back to them. But so one, and I think this is probably a very common one, is encoding and decoding. And so to like start to illustrate that, you can imagine just with what I have here, let's try to make a method. Let's call this like render. And this is going to take a value that's a value of type A. And it's going to say, it's also going to require us to have a schema for A. And it's going to generate a string representation of this. So you can imagine how we could start to, I'm going to just take this out here because we're not going to have that right now, how we could basically start to pattern match on this thing. And we could use the schema to describe how we want to render this thing. So encoding and decoding is one really valuable use case. And I think part of what makes that so valuable is think about separating the structure from how to encode the structure. So one of the things, if you notice about like ZIO HTTP, we needed the schema versus like a lot of times you might have maybe in the past, let's say if you were working with a database, you would maybe need JSON encoders for your types, right? Because like you're making them in JSON when they go into your database. And so you need these like JSON encoders and decoders to work for all your types. But if you really think about that, like that's not actually the ideal way to do it, because that JSON encoder really needs to do two things. One is it needs to understand the structure of your type. And two, it needs to understand how to encode that structure in a JSON. And so when like for your database access, you're using these JSON codecs everywhere, you're kind of hard coding yourself to everything is JSON, which is fine. I mean, if that's what you're doing, that's fine. But the reality is that maybe you don't want to use JSON, right? Maybe you want to use Bison. Maybe you want to use another format. And that's really where this starts to come in with like ZIO HTTP. Because like imagine, so we're going to generate some endpoint for ZIO HTTP, and we're going to accept or we're going to return this person type here. So one thing they could have done is they could have said, well, you need a JSON encoder for that or a JSON codec for that. But that's kind of assuming that the encoding scheme you want to use is JSON, which might not be what you want to use. And then like you could imagine, like, does that mean you have to have two separate variants of all these methods? There's like the one that uses the JSON and one that uses Bison or something else. And that pretty quickly gets to be a disaster. Versus if we just say we need to have a schema for this thing, then the framework can decide, or the user of that schema can decide how they want to encode that thing. Using any library that can generate a codec based on the schema. So like in the ZIO HTTP case, like there's like a binary codec that you can generate from a schema. There's a JSON codec. And so you could have the same type signature that just expects a schema, but then let's say maybe based on config that you load, it could do all the encoding and decoding in JSON, or it could do all the encoding and decoding in binary or something else. So it gives you this nice separation here between these two things. And I'd say that's like, right, if we're thinking about kind of the most common use case for these things, I think this is like why you use ZIO's schema for the first time. And you saw that's kind of why we used it for the first time when we were using ZIO HTTP, just because we wanted to send this stuff over the wire, and it took care of that for us, right? It made sure that everything we're working with could be encoded and decoded. But once you start to go down this road, there are a bunch of other interesting things that you can see doing based on this. So like one of them could be migration. So imagine, let's say we've got a final case class person 2, and we decide people are getting really old here. So now their ages are going to be long. So we're like, become Methuselah and more, people living more than 32 million years. And so you can imagine that you want to have some way to migrate between these. And you can see how we could look at like the structures of these two, and we can see that they're compatible other because they don't get old, yeah, that they're compatible other than having this field be different. And we could potentially look at this field and say, in this case, we can basically just like upcast from one to the other. We can just do too long here. So this might be supported out of the box, or maybe we could identify these are the changes that need to be made and require a function to do that. But so migration is another use case for this. Another potential one is validation. So we haven't done it here, and it's in a way it goes beyond kind of the minimum we need to describe like this person here. But we could imagine that we also build in some validation here where like maybe this person, the age has to be positive, and want to build that in. So those are like a couple of, I would say, the simpler examples of how we start to use the structure of this data to do that. So let me see if I can actually go to ZIO Schema here, and we can look, hopefully, at ZIO Schema itself. Worst case, I'll just do another screen share, but I wish VS Code would. Okay, let's see. No, not this one. Not this one. Okay, all right, we're going to do it the old-fashioned way. I am going to open ZIO Schema here. So work says, how can we describe validation in schema? Let's take a look. So let me, okay, I think, can people see my screen here? Can I just go thumbs up, thumbs down, make sure the screen share is working here? Okay. So let's look at, let's see. Okay. So here is the fancy version of a little bit what we were doing. And so I'll try to at least hit on the why of some of these things, but we can see there's definitely some more stuff here, but we can also start to see some similarities, right? So in the actual ZIO schema, they call that a record type, which I think is actually the same thing that we had in ours. And then they call it record, maybe it's a record type. They call this case class 2. We had record type 2, but it's got the same thing with these 3 type parameters, where this last one is the actual type of the, like, say, the person. And this would be like this is the name. This would be like the int. And if this, or sorry, this would be the string. And if this was the age, this would be the int. And internally, right, they've got this represented as they've got these 2 fields. And if we look at, let's see if I can go to the case class field. There we go. So a field has exactly the same things that we looked at so far, but in this case, it also has this thing called a validation. And let's see if I can find. So this is another example of describing something as a data structure. So here, this validation thing is basically a predicate. And they've got a bunch of ways of combining them, and then they've got some pretty simple predicates. So this is another thing that if we wanted to, we could kind of do a very simple version of ourselves, but we could build in validations here. And maybe we can actually do this if I can, let's see, go back here. So if we wanted to, right, we could kind of follow a similar thing. And we could say each field has a validation. And so let's maybe explore a little bit this validation type. So we could say, and we'll just do a very simple one. So say, I'll make this a sealed trait validation. And so we could have something like an empty one. And then I could have something like face class, let's say greater than, right? Maybe this value is going to be an int. We decide a little bit how we want to represent this, but we can just represent all this as its own data structure. So again, kind of going back to like what they had here. They've got like some of those exact ones, right? So they have greater than, less than, and you can see they added some more fancy stuff here because they want this to work with a variety of numeric types that aren't necessarily ints or just an int. So they have this num type here that basically, well, you can say it has these different types here. So a lot of what you have in ZIO Schema is just really this, like, I'll call it precise domain modeling, right? And I think as we go through this, none of these things are really rocket science in a way. I mean, I think we saw we could build up to them pretty straightforwardly in what we were doing. But we're just kind of being like very precise about describing all of these things as data. So you might notice one of the things that even that validation, they were very careful to do is there were not functions there. Everything was data because we want all of even these schemas themselves as much as possible to be things that we could serialize, that we could send over the wire, that we could introspect on. Any questions on any of that so far? Nathan is typing. Oh, nice. No, I appreciate that. Sometimes through the internet, you know, it can feel like you're sending stuff out into the ether. So no, it's good to know people are, this is making sense to people. Yeah, I see. Okay, one is good. So yeah, if we then let's go back to ZIO Schema for a second. And let's look at some of this, see if we can find a good example of one of these. I just want to see if I can show you like the log where we have one of these. Here, let's see. Oh, I think it might be in the, let's see if we can look at the JSON. Yeah, so here you're starting to see, now the flip side of this is we've got all this like great stuff of we can describe all these different types. And I think if you go back to the schema here, if I look at like, I think there are only like 12 basic types that extend schema, but then some of them have like their own things. Like if we look at this, like this primitive, let's see, extends. Let's see, where's the type? basically there are a ton of subtypes of schema. So that's kind of the library author pane side of this is like you'll see, this is the logic to actually derive the JSON encoder and decoder for one of these types given a schema. And you can see there's like lots of, right here, every primitive type that's represented. You can see it's bigger than just the list of primitive types we had. And so each of those, well, we just go directly to the correct codec from ZIO JSON. But then if we have things that are case classes or records, right? We say, hey, it's a case class 2. Let's go to the case class encoder. Well, what does the case class encoder need to do? Well, first it needs to do a bracket, right? Then it needs to go through and do each of these types, and then it needs to put the colon between them, and then it needs to do the other one. So it's one of those things that, like, the great thing about ZIO Schema is like you have all the information to do this. The, like, I guess, library author pane is you can see there's just like you got to handle all these cases and do it. But that's kind of the like ZIO modus operandi, as I kind of joke sometimes, it's like library author pane for user gain. So the idea is that the people who contributed to ZIO Schema, one time you do this work, and then anytime you have a schema, you can derive a JSON codec for it. And this is ZIO Schema JSON, but we've also got ZIO Schema Avro, so you can derive an Avro codec for it. And notice that if you have 2 of these, that also means you could transcode between them, right? Like, let's say you have a ton of data that's in Avro, you could, with this, just do something that's automatically going to decode it all and re-encode it all in JSON. And that's all with ZIO Schema here, or protobuf, or thrift. So you've got a lot of functionality around that encoding, decoding, transcoding. There's some other stuff here around like optics. So I don't know how many of you have worked with optics, but this is basically a way of kind of describing changes to, like, digging into small parts of big data and just changing that one part. And there's a ZIO library called ZIO Optics that does that. But a lot of times you don't want to drive the optics yourself. And so this actually lets you kind of generate the optics based on having a schema for something. So there's a lot of cool stuff in here. And I think there's also a lot more to be done. I think there's like a lot of issues here. And if people, not issues as in problems, but I guess issues as in like enhancement opportunities. So if people are looking to get involved in something, I think this is a cool one. You can see there's definitely some aspect of you're kind of going to be like getting into the weeds on some things, but I think it's also kind of an opportunity to work on one of those foundational libraries that, like, if you think about ZIO HTTP, really important library, doesn't have that many dependencies, right? The goal is to not have any we don't definitely need, but like this is one of them. And this gets used every time something gets encoded or decoded. So if you're working on this, you're definitely having an impact that gets much broader. Okay, let me do a couple of questions. I think we're probably at a good breaking point here. So Nathan says, one thing I've been thinking about that I'd like quick feedback on. Any thoughts on whether or not an HCL Terraform flavor would be useful, helpful? I tend to think yes, except the Terraform, for example, will accept JSON as well. Yeah, I mean, I think generally more formats are better. And I mean, some of them can live here. Also, like there's none of these little like all of these are separate modules, you'll notice, and none of them have any special access by being virtue of like the ZIO organization or part of this repository. So, if you had some other, like, even if you had another JSON library and you're like, well, this one uses ZIO JSON, I don't like ZIO JSON for whatever reason, you could write your own derivation of the JSON codec in the JSON library of your choice based on ZIO Schema. Or if for some reason we're not supporting some protocol that you want to support, like either we can add it here or you can have your own library for that. And I think, just like ZIO, there's kind of ecosystem around it. I think the goal is really that there's a ecosystem around ZIO Schema of both libraries that are consuming it, like ZIO HTTP, but also libraries that are either they're doing other things with it, whether it's codecs for other formats or was other fancier things of like you could imagine kind of like a chimney type thing. I think there are a lot of things that you could do with this. And then Damien, yeah, sorry. Well, I mean, I know you're super busy with other stuff, and we also changed the time, which doesn't make it easy, but we'll have it on the video for you. And I mean, I have a feeling you think I probably know a lot of this, and we'll have more sessions on ZIO Schema. Um, all right, so I think hopefully going back to our not here, but our symposium. Hopefully this has been helpful for you to get a sense of what a schema is and maybe also isn't, like with that like interface example. But basically every time we're talking about a schema, like when we were here and we derived the schema for the actor request, this schema that we derive basically looks like this. Maybe it's like a little bit fancier because it has like the possibility of doing this validation or whatever, but like most time, there's no validation. So it this is a really good mental model actually of what this schema is. And hopefully seeing this now, you've got a better sense of like why you can use this to generate a codec for something, whether it's a binary codec or a JSON codec or something else. So I think definitely if people have follow-up questions now, we can do them, or later on we can do them. But I think maybe when we spend some more time on ZIO Schema, it would be neat to explore some of the use cases. And we can start off with just going through how you both maybe derive the schema and generate some of these codecs. But I think we'll find that's pretty straightforward. But also maybe look at some of the other things you can use it for, as well as maybe some of the things that you could use it for that also need more work and need more contributions, and we can explore that together. All right, so I'm going to give folks one more minute here for questions, and otherwise we will call it for the day. And remember, next week we got Active ZIO HTTP with Nabil, and the following week we got Caliban Performance with Curie. All right, well, cool. Well, thanks so much, everyone, and look forward to seeing you next week. Have a wonderful rest of your day and a wonderful weekend.